Alrighty, we have trigonometry, functions, and quadrangles. So 1.3, so this is amazingness, right? Okay, everyone wants to be here? Yeah. Okay, yes, it is kind of hot in here. So, yeah. Alright, so trigonometric function, let x and y be a point on the origin, other than the origin, on the terminal side. Now, what does the word terminal mean? If you have a terminal illness, you dead.
Oh, terminal.
Terminal.
So that side of an angle?
You want to take that
Oh, yeah,
Thank you. All right. So terminal means that is going to be where it's going to end at. Okay. It's the side of an angle, angle theta in standard position. Standard position is important because that means it's starting from the origin right here. Okay, the distance from the point of the origin is here. This is your Pythagorean theorem just worked out. It's your Pythagorean theorem worked out. So now in this time, your x direction is your left and right. Your y direction is up and down. Yes?
Yes.
Thank you. So we're going to go through and find a couple of these things. So this, highlight, underline, italicize, go through. These are the ones that are going to be the most important. I'm going to hit these all day long, all semester long. I'm going to go over this over and over and over again. So you guys, when you guys are done with this, are going to be very fluent in what to do with this. There should be highlighters in the box too. So if you guys want to check the box there might be a highlight. There should be highlighters in there. Okay. Okay, good for you. All right, so now when we're doing this, y refers to my sine value. Y is going to refer to my sine value. X is going to be my cosine value. R is going to be the radius of a circle. When we're talking about a unit circle, the radius is always going to be 1 in a unit circle. So if it's just the regular unit circle, radius is 1. So if it's y divided by 1, sine value would be just what? Just y by itself, right? That's what we're looking for. So in the unit circle, radius is 1. I'm looking for only the x, right? So cosine would be the x. Now, tangent. This is another good one. This is a ratio of y to x. This is going to be sine over cosine, right? Where x cannot equal 0. Why cannot x be equal to 0? Because why?
You're looking for
Say it. Can't divide by 0. It is going to be undefined. I cannot have it. I do not like it here or there. I do not like it anywhere. Okay? Now, these are going to be the reciprocal identities. Now, reciprocal means flip over, right? Say yes.
yes.
Okay, good. Reciprocal identities mean I flip it over. So therefore, if sine is y over r, cosecant is r over y. Where y cannot equal 0 because that would be, again, divided by 0. Does that make sense? You're going to reference this a lot. Now, for this right here, the terminal side of angle theta in standard position passes through points 8, 15. So, what does 8 represent? The which one? X. 8 is the x, 15 is the y. So, left and right is 8, 15 up and down. So, if it's positive, now think of your number line on your coordinate, your Cartesian graph. Okay, positive 8 is to which direction? To the right. Positive 15 is up. There we go. Makes sense? So that's where I get it like this, to the right and up. Right there. Easy?
Yeah.
Okay, so now the next thing we're going to find is we're going to solve for
Theta?
no, we're going to solve for r. Not theta yet. We're going to solve for r. So this one right here is going to be my r value. Okay, we're going to solve for r here because I gave you a formula back here, right? We can solve for r, can't we? Yes. Let's do that. So we're going to solve for r. So I'm going to say that r is equal to, you guys help me out, what goes inside?
X squared.
X squared. What is x squared?
8 squared.
8 squared, thank you. 8 squared plus
15 squared.
15 squared. There we go. So now in your handy dandy calculator, you guys make sure you go to the scratch pad right here and check that out. Make sure it's correct.
What do you mean it's correct? It's incorrect.
Okay, when you look at that calculator, what was the first thing you guys had to check? I told you yesterday.
The degrees.
Degrees. Is it in degrees?
Yeah.
Okay, make sure it is.
How? Do I change it?
Yours is not in degrees?
It's in rad.
Rad? Okay, so hit doc. 7. See where it says angle?
It says 17.
It says radian, right?
Oh, what? No.
Yeah, mine says that thing.
There's no.
Okay, document settings right there. Sorry.
Oh,
I forgot that one. Document settings.
radian.
What's gradient?
Okay, so what do we got? So it's going to be r is equal to square root of 64 plus 225. So r is equal to the square root of what? 2 what? 89. So r is,
15.
it's not 15,
17.
17, right? There we go. R is 17. Now, here is a word of advice. R is always positive. My radius is always positive. The radius of a circle is always positive because that's going to be my distance from 0. The R is always positive. It's almost like I could say this, you know, rhythmically to get you to write it down on a piece of paper because it is important to be. Okay, there we go again. Ah, wait, here it is right here. All right, so now, we know, we said y was what value? 15.
15.
X was?
8.
R is?
17.
Okay, so now, tell me what sine theta is going to be.
Oh, okay.
Cosine theta. Tan theta.
15 over 8.
Cosecant.
17 over 8.
Okay? Secant, 17 is what?
17 over 8.
Cotangent.
8 over 15.
I have to.
Está muy fácil.
See,
Speak.
should I go to the restroom?
You gotta say. Do you have to ask?
I didn't know if I had to ask or not.
All right, so, okay, so let's take a look at this next one right here. Example 2 says the terminal side of an angle theta in standard position passes through that point. Find the values of the sig trig functions. Now, there's something I'm going to give you guys which is going to help you out a whole lot. Okay, a whole lot. So, this, okay, quadrant 1, quadrant 2, quadrant, and quadrant 4. Now, information I'm giving right now is going to be so beneficial, you're going to be like, oh yeah! Okay, in quadrant 1, what do I know about my x and y values?
Positive.
So I have positive, positive, right? In quadrant 2,
Positive, negative.
Negative positive.
negative, positive. The x value is to the left, right?
Yeah.
So that's going to be a negative and a positive, right? Because the y value is still up. Quadrant 3, negative, negative. Quadrant 4,
Positive, negative.
positive, negative. Okay? That's going to help you out when you guys are doing this later on, all right? All right, did you guys write it down? So this one right here is in quadrant 3, right?
Yeah.
Okay, find the value of the 6 trig functions of this one right here. Okay, so yeah. So I just want to make sure it actually had it set up already. So now, what's the first thing I gotta find?
Points.
Nope, I gotta find what?
R.
R, thank you. To be able to do that, all 6 trig functions, right? I need R first, don't I?
Yes.
Okay, so let's go through and solve for R. So R is equal to the square root of,
X squared.
okay, so negative 3 squared. Now, when you're squaring a number, make sure you put parentheses around it if it's a negative, because you have to include the negative. Because a negative times a negative is a
Positive.
thank you, plus negative 4 squared.
9 plus 6 is
Yep, so R equals square root of 9 plus 16, R square root of 25,
and 5 equals 5.
R is 5, right? Very good. So I have my value, so R is 5. That's going to help me out for the next part. Okay, so right here, okay, it still has this right here, kind of like we did on the previous one, right? So all that stuff highlighted. So sine. Sine is going to be what over what?
Negative 4 over 5.
So it's negative what?
4 over 5.
Negative 4 over 5. So when you're writing the negative, it can go in front of the fraction or on top. Can it go at the bottom?
No.
Why?
Because R can never be negative.
R cannot be negative. R cannot be negative. Okay, cosine. What is cosine?
Cosine is negative 3 over 5.
Very good. What is tangent?
Negative 4 over negative 3.
So it's-
negative in front.
So it's negative 4 over negative 3, but two negatives make a? So this one comes out to just 4 over 3, right? Okay, that one's positive there. Now, cosecant.
R over Y, so that would be 5 over 5 negative 4.
Very good. Okay, where else could the negative have gone?
The front there.
In front. It can go in front, okay? So if you see it out front,
Still the same. It goes in the bottom.
okay, if you see it out front, you need to understand R can't be negative, so therefore it has to go with the other number. Okay? Secant, what are we going to have?
5 over negative 3.
And cotangent
Negative 3 over negative 4, so it's still positive.
equals positive 3 over 4. Very good. You guys are on it. There's example 2. Okay, here goes example 3. Find the 6 trig functions of the values of the angle theta in standard position of the terminal side of theta. We could use any point except 0, 0 on the terminal side. So, okay, so we're starting here, and we're going to choose 2. Okay, it's going to help out. Okay, you're going to be given a line, and you just have to find a point that has a good y value also. Because when you are doing this and you're plugging in numbers, you don't want the y value to have some weird fraction. So you can't plug in, so if I plugged in 1 for x, it would still work. Wait, hold on, let me see. 1 plus 2y equals 0. 2y equals negative 1. So y equals negative 1/2. So you wouldn't want to use 1 here, because as you plug in your x and y's to try and figure out your other missing side or missing angle, you don't want fractions because it's going to mess up your numbers later on. Okay, it's going to make it messy. Okay, go ahead, plug in numbers and wait till you actually get a non-fraction. You need an integer here. Okay. All right, there we go. So we're going to choose 2. Okay, so once we choose 2, that means that we went with 2 plus 2y equals 0. And I need to solve for y, right? I need to get my other point. So minus 2 from both sides. So 2y is negative 2. Divide by 2, right? Y is negative 1. That's what we have down here. Okay? And that's given this. Most problems right here, most problems are not going to give you both x and y. You have to find the one or the other. You have to find one or the other. Okay, now, what does this one right here mean? Look at that.
X has to be bigger than 0.
X has to be greater than 0.
Greater than.
Greater than, right? Greater than or equal to. So it can equal 0, right? Now, alligator eats the bigger number all the time, right?
Yeah.
So numbers that are greater than 0 for the x-axis is moving to the right, isn't it? That's important. So that's why I picked numbers over here on this side. If it said less than 0, that means it's going to go this way. Okay, it will go this way on my line. Does that make sense? Okay, so the numbers that you plug in would have to be negative numbers instead. All right, so I have my x and I have my y. So 2 and negative 1. Okay, so r is square root of
2
Square.
plus.
negative 1 squared.
Very good. All right, so r equals square root of what is 2 squared?
So number 4
Plus,
1
so r
equals
square root of 5. And guess what? That's it. And we left with that part. Now, I'm going to have to also teach you this thing is called rationalizing. You guys did some of it in Algebra 3-4. Okay? Rationalizing means I cannot have a radical in the denominator. So, for this instance right here, for sine, so my y value is going to be what?
negative 1 negative
So it's negative 1
over 5.
rad 5. Now, to rationalize, I multiply by the value of 1. Okay, value of 1. So if I take x and divide it by x, what do you get? Just 1, right? If I take 5 divided by 5, what do I get? If I get rad 5 divided by rad 5,
You get 1.
you get 1. So if you multiply anything times 1, you get the same number. Okay? So 5 times 1 is?
5.
100 times 1 is?
100.
We're just changing the way it looks. Okay? We're not changing the value, we're changing the way it looks. So, multiply top bottom, rad 5, which gives me negative, right? Negative, rad 5 over square root of 5 times square root of 5. Square root of what? What's 5 times 5? 25, right? So, the square root of 25 is going to give me 5. So, the rads go away, so I'm left with just 5. Are we okay there?
Yeah.
Okay, next one, cosine. Cosine, what was the cosine? 2 over
2 over rad 5.
rad 5, right? And again, what's the word? What's the word of the day?
Rad.
All right, class.
Rad.
Oh, you got to sneak at this. All right, listen. When I say class, you say yes. Class?
Yes.
Class?
Yes.
Okay, so when we're doing this, the word of the day is rationalize. Say rationalize. Everyone, rationalize. Thank you. So we're going to rationalize this right here. So I'm going to multiply top and bottom by
That's 5. From the rad 5.
rad 5. Very good.
You get 5 on the bottom.
2 rad 5 over 5. There we go. Yes?
Yes.
Okay, those are good. Now for these next ones. Tangent. Tangent is y over x. So the y value is
Negative 1.
-1 over 2. Secant.
Secant is
Rad
rad 5 over 2.
5 over 2. Do I have to rationalize that?
Now,
No, because the radical is not in the bottom. Okay, what about cotangent?
that's negative 1 over 2.
Uh,
Oh, yeah. X negative
2 over -1, right? And cosecant.
Rad over 1. Negative 1.
Rad 5 over what?
Negative 1.
There we go. Está muy fácil. Can we do it? Sí se puede, right? All right, so I'm going to leave off right there for today. You guys are going to be amazing and work on these problems.
Bring up the homework.
All right, you guys, don't forget, like and subscribe, right? Smash that, what's that alert button thing? The bell? Yes. Yeah. Notification. Okay, so if we get 100 views on this video,
Doing a giveaway, Hannah.
yeah, I'll do a giveaway. But 100 views by when? Give me a win.
Extra credit.
Next
Next week, Friday.
Next week on Friday, okay, we'll have a giveaway.
We're giving
Hey,
an
will it
iPad.
be food though?
We're giving